Okay, Chapter 3 is a new chapter and a new topic. In this unit, we will learn about rigid motions, a very specific group of transformations whose size stays the same. The first transformation is in 3.1, and we're going to talk about reflections. As mentioned before, a rigid motion is a transformation whose size stays the same. When we refer to the pre-image, we're going to be talking about the original image. And when we refer to the image, we'll be talking about the transformed image. A reflection is a mirror image, or also commonly called a flip. This is reflection notation. And from this reflection notation, right here we have the line of reflection. The R stands for the reflection. Inside the parentheses tells you what is being reflected. And then this is the notation for a transformed figure. So this is triangle ABC. This is triangle A prime, B prime, C prime. And you can see that over here in the actual image. This is triangle ABC. And then it was reflected over line M, which is in our notation, that's our line of reflection, and we ended up with triangle A prime, B prime, and C prime. Two things that you want to remember. Reflections are rigid motions. They keep the same angle measures and the same side lengths. That's going to be important later on. Okay, let's talk about reflecting a figure across a line. When you reflect a figure across a line, you're going to sketch a perpendicular line from each vertex, so G, H, and F, to the line of reflection, which is line L. That's this right here. Then you're going to sketch the same distance across the line of reflection. So sketch this far and then that much farther. And sketch straight down here and then this much farther, and straight here and this much farther. Then we're going to connect those endpoints for the transformed figure. So let's take a look at this and see how it works. I need a perpendicular line though. Otherwise my measurements are not going to be accurate. So if I'm starting at vertex G, I can use this straight edge, which is just a post-it note, and you'll notice that it's lined up next to line L. So this line, and it's not a main part of our diagram, so I'm just going to do a dashed line right here. I'm also going to make a note that that's how far I went. Okay, now I can flip this over, line it up again, and continue my line so that it is still perpendicular. I'm going to go the same distance, which is right here, to that point. Now I'm going to do the same thing with H. So here is point H. I'm going to line up this post-it note, and I'm going to draw a dashed line down to line L, and I'm going to mark where that point was. Okay, now I'm going to line it up on the other side, making sure that it's still perpendicular, and I'm going to continue my line same distance that I went before, and then at the end I've got another endpoint. And then finally I'm going to do the same thing with F. So here is my vertex F. I'm going to line this up so that it is perpendicular to this line, or as close as you can get it. And then I'm going to make my dashed line here. I'm going to mark where that point was, and I'm going to continue it on the other side, the same distance. And right here, I'm going to have another point. Okay, now I'm going to connect my endpoints with a straight edge. So here's this one, and these two, and this one. And we're going to rename these. So G becomes G prime, H becomes H prime, and f becomes f prime. And that is reflecting a figure across a line. Okay. Let's reflect a figure on a coordinate plane. This is a lot easier than what we just did, because let's say, for example, that we're going to flip quadrilateral FGHJ over the x-axis, and that's what it says right here. So we're going to graph and label it, which I have already done. You may want to pause the video so that you can add that to your coordinate plane. We are graphing it, or reflecting it over the x-axis. That's what our notation says right here. And so I'm going to start with H, and I'm going to count 1, 2, and then I'm going to go 2 more. 1, 2. Kind of just exactly what we did before on the other page. Now I'm going to go 1, 2, 3, 4, and 1, 2, 3, 4. And over here with F, 1, 2, 3, and 1, 2, 3. And finally J, and J is already there, and so it does not move. And so now we can connect those points again. I like using the Post-it notes. I use, sometimes I use like a playing card too, if I have one from a set that's not complete and I don't need it for anything else. Kind of looks like a Pac-Man here when you're looking at it, but here is our reflection. I'm going to go ahead and label these points too. So this will be H prime, G prime, F prime, and J prime. Okay, and that's all there is to reflecting it over the x-axis. If we were going to do this over the y-axis, we would count to the y-axis and keep going. This one would stay the same. This one would go this way, whichever way it takes to get to the x-axis, and then it would keep going. So this would be kind of flipped over that y-axis. Okay, let's take a look at a couple of points that make reflecting it easier, especially if you're not looking at a coordinate plane, if you're just looking at a set of ordered pairs. If you reflect any point on the coordinate plane over the x-axis, you're just going to change the sign of the y. So pxy becomes px negative y. So you just change all your y signs, and that's going to be reflecting it over the x-axis. Likewise, when you reflect over the y-axis, you change the sign of the x. So the pre-image is pxy, and the image is p negative xy. So if you're reflecting over the x, change the sign of the y. If you're reflecting over the y, change the sign of the x. Okay, last thing that we're going to do is learn how to describe a reflection in the coordinate plane. And what that means is figuring out what the line of reflection is. So if you take a look at the example over here, the first thing that you're going to do is find the midpoints between your image, or your pre-image, and your image. So if I'm looking at this one right here, then I have a midpoint right here, and then between the K's I've got a midpoint right here, and then between the M's I've got a midpoint right here, and they all lined up nice and neat, so I can connect those points, and that's going to give me my line of reflection. Okay, so my line of reflection is going to go right through there. Okay, once you have the line of reflection, then you want to write an equation for that line. And you write an equation the way we did in the last chapter by finding your slope and your y-intercept and writing it in the form slope-intercept, so y equals mx plus b. Okay, let's go ahead and take a look at this example over here. I have already put these on here. You may want to pause the video to do that. This is CDE, and this is C prime, D prime, E prime. Now, they don't quite fit, so you're going to have to estimate just a little bit, but it still works. Okay, so if I'm looking at these points, I notice that they're flipped and their signs are changed. Okay, so if just their signs were changed, and say C prime was -3, -8, then I would assume that they were flipped over the y and over the x, which would be kind of like this. It would be over this line right here, which is kind of in between the x and the y. However, these are not only these are not only negated, they're also flipped. It's negative y and negative x. So instead, it's going to be going in the negative direction. So if I kind of test that theory, then it looks like the origin is right between them. Okay, and I'll go up here a little bit. Still right between them. And if I go down here, okay, still kind of right between them. So you can kind of visualize the way that that line is right between the two figures. Okay, so we're going to go ahead and draw that line across here. All right. And then if we figure out what the slope is, we're going down one and right one, down one and right one, down one and right one. So that's negative 1 over 1. And negative 1 over 1 is just equal to negative 1. Okay, also, it goes right through the origin. That's where y equals 0. Okay, so our y-intercept is going to be 0. So we're looking at y equals negative 1x plus 0, or if we want to clean that up a little bit, we don't really have to have the 1 and we don't have to have the 0 here. We can say y is equal to negative x. And this is going to be the line of reflection. So, triangle CDE was reflected over y equals negative x, and that gave us triangle C prime, D prime, and E prime. And if we want to write that out, it would look something like this. This would be our reflection, and it would be over y equals negative x and triangle CDE. And that would be a description of our reflection. Any questions? Make a note of them, and you can ask me in class. Have a good weekend.